This is the results for the existing highway for the City Sky and the new proposed design, which was done by two engineering firms. And as you can see, we have a very high collision modification factors in the existing highway, but in the new design we have a very low collision modification factor. That means that we will have less collisions per year. Also for the design, this was for the collision prediction using the input data of lane width, shoulder width, and these stuff. But if we go for the design consistency, we will have different also CM values, that is difference from the existing highway and the new design. We will combine all of them and we will get the total collision. We will combine all CMF values for the existing, for the design consistency and the collision prediction, and we will get the CMF value for the existing, and we can estimate the total collision frequency, which is here in this case 19.9. We compare actually this number with the actual observed total collision frequency, and it was for 17.69 collision, which is very close to that value. In the new design, we are estimating a total collision frequency which is 7.72 collisions per year for the using the CMF values for the new design. As you can see here, this is a comparison between the estimated base condition. We have 7.63 for the existing, and then the estimated for the existing condition we can 19.16, and the new design we are estimating that we have 7.792 for a base, but we are estimating a new design of 7.72. The observed was 17.67 collision per year. If you want to estimate how much collision reduced, we can get 19.9, which is the estimated, minus the estimated in the new design. We can get 11.47 collisions per year. And if we want to get the average cost per collision, we have some values for the fatal injury and property damage only, and we can get the cost. Approximated cost that is used in this case study was 4.2 millions per fatal in Canada, 4.2 million in Canadian dollars, and 100,000 for injury and 6,000 for property damage only. If we get the average for the all costs and all number of collision, we can get 111 $375 per collision. Using this collision and using the collision reduced, we can get we can have a very simple benefit cost analysis, and using the discount rates from 4 to 8, and using the service life of this project starting from 15 years to 25 years, the benefit can, the net present worth for the benefits of that collision reduced can ranges from 10 or 11 million Canadian dollars up to 20 million Canadian dollars. If we get the percent of the total project cost, we can get from 0.36 from the total cost, assuming that the total construction cost is 30 million Canadian dollars, and it can also reach 0.67 in the case of 4 discount rate and the 25 year service life. As a conclusion for presenting this very interesting paper, we can note that the collision prediction model and the collision modification factors allow us to quantify the safety performance, and this is a very nice and interesting systematic approach that is applied to this project. We can also say that the CBM and CMF value is available from the UBC Research Civil Engineering, Dr. Said, and a lot of other graduate students, and a lot of UBC research has been done to get this CBM and CMF values, and the IHSDM used by the Highway Federal in the US. And also the new approach developed for the design consistency to get the collision modification factor was presented in this paper. This approach supports the difficult highway design decision in order to really evaluate what safety can be done. Thank you very much, and we are welcoming any questions or comments in order to discuss about this paper. Thank you very much for listening.